Hello, all you loyal listeners, and welcome back to Manwatch Required, the inspection podcast, where our mission is to not only entertain you, but to try to shed some knowledge at the same time. On today's episode, we're going to teach you how to bake a cake.
Baking cakes today. Hey, Scott.
Yeah, I guess so. We'll see if that makes any sense by the end of this.
We'll see what your flavor is. I think this episode's going to be very good. It's going to be a good learning episode. We're going to, I don't want to say attempt to, but we're going to go through ASME Section 9, which seems to kind of be a contentious point between inspectors. Maybe not contentious, but it's something that a lot of people don't fully grasp 100% all the time, and you're in for a treat because Scott, this is Scott's wheelhouse.
Oh, easy with that.
This is not a good week for me because since we're both sharing the mic this week, it's my turn to sit on Scott's lap, and I can tell you he's very excited to talk about welding procedures and qualification. Yeah. Scott, this is going to be good. This is something that you're not only passionate about, but I think many people would say you're very knowledgeable about. And
yeah, or at least at one point it was anyways. It's kind of the last couple of years been leading down past a little bit away from this, but yeah, at one time this was, all I really did and had a bit of knowledge of it, or at least could navigate my way around through this daunting code book. But yeah, attempt to go through section 9. I think you put it pretty well. We'll give it a shot here, but I think this is one of those things that a lot of people don't fully understand, and they don't realize they don't fully understand. And a lot of stuff gets, I don't know if stuff gets missed or not per se, but it doesn't really get scrutinized the way it should. And I want to say more specifically on the owner side of things. The people on the construction end are probably a lot more familiar with this stuff because that's what they do day in and day out, but ultimately it's usually getting reviewed and approved by somebody on the owner side, so they should be close to as well versed, if not more, in this than the construction people.
Yeah, and actually weld procedure review is actually a big part of in-service inspection, or a big part of a in-service inspector's job, especially for repair of pressure equipment, and also in shop fabrication, where you want to make sure you're using the right procedures that follow the client spec and also meet the code requirements for the construction of that. Yeah,
it's kind of a few avenues there. I think to start off, we're going to go through a bit of a Section 9 review and how that works. But there's also your code of construction. You don't want to forget that. That's applicable to new construction, also to repairs as well, because that's pretty much how it works in Alberta as we go back to the original code of construction. Got a little bit of registration we'd like to talk about, and then you got your client specs, which I don't know if we can get into those too deep, but we'll see where we get to with that. It's just, those are kind of all the avenues you definitely want to touch on when you're reviewing a procedure. It's not just a Section 9. Really, when you think about it, Section 9 kind of has the least to do with it, other than it will meet all that criteria. But your code of construction and your client specs and that are probably the more stringent, more important things you want to look at.
No, for sure. And I think something to point out is that Section 9 was kind of developed specifically for the ASME boiler pressure vessel codes, even though you can use the basic structure for procedure qualification and welder qualification for stuff outside of it. It's kind of meant to fit right in with, things like your B31.3, B31.1, Section 8 kind of stuff, and kind of gives you the guidelines on how you need to qualify your procedures, qualify your welders, and, it's your basic guides. Like Scott said, it's how to bake your cake. It's going to be your recipe. I don't want to jump in. I know you really kind of wanted, it's going to be your recipe for your weld, right?
I guess we should elaborate on that. I already forgot that I said that at the beginning, but yeah, maybe before we jump right into it, let's just, you got to have a bit of a mindset going into this code, especially if you're not familiar with codes in general. You got to think about the welding procedure as a mechanical integrity standpoint. That's all you're trying to prove. You're not trying to prove welder skill or something like that. Whereas when you're testing the welders, you're going to be looking at their skills. So we're going to point that out on a couple line items here and just kind of the differences, and we'll try to explain that and kind of what's going through the mechanical engineer's head when they put this book together. But where the bake a cake thing comes from, just think about it this way. If you're going to bake a cake, you got to have a good recipe and you got to follow the recipe. And if you do everything on the recipe as you're supposed to, you should come out with a nice looking cake. No different than a welding procedure. The PQR is your recipe. If it's a good recipe and you follow all the variables and do everything according to the recipe, the PQR, you should come out with a perfectly good cake, or a WPS. So that's kind of where that comes from. It's something I picked up years ago from somebody, and I think it's just an interesting way to explain it quickly. And
no, you can't get much of a more simple explanation than that. Like, if you want something to turn out the way you expect it, you got to follow the plan or procedure on how to create it. So I think that's a good way to explain it.
Sure. It's different anyways. Keep it entertaining.
Where are we starting off here, Scott?
Well, let's get into section 9 first, but before we jump into it too much, maybe let's just go over kind of how it's laid out. We're not going to go through the whole thing. There's a few, almost half the book, well, a third of the book or so, we're not really too interested in it, at least for our line of work and what we come across, brazing and plastic fusion, things like that. I'm sure there's industries for that, but it's not something we really deal with. So we're going to do a bit of a case study, if you will, through like a small welding procedure and kind of how you would review that. So basically looking at this code book, how it's laid out, it's they call it articles, but it's basically chopped up to a bunch of sections. So you've got Article 1, that's just a bunch of general data. So a bunch of welding requirements, a lot of general information is a good way to put that. Then the second section, Article 2, so that's all your 200s. All the paragraphs are QWs, so QW 200, all the way up to 290, whatever it is. So that's all your welding procedure specific information. And then you move into the next section, Article 3. So that's all your QW 300s, 300 to 380, whatever it is. Now that is all your performance qualification information. So that stuff is specific to welder performance qualifications, so the welder testing. So these two sections, it's very important not to interchange the information, because what you'll find if you get into Article 2 or Article 3, vice versa, you're going to find all the same variables, or a lot of the same variables, but with different criteria. So you want to be really careful you're in the right section. Like if you're looking for something specific to a welding procedure, you want to go to 220, not 320, or vice versa. That's something that can really trip you up, because the wording is going to be very similar, if not exactly the same, just with a little different criteria. Moving on to Article 4, so that's your 400s. A lot of that is going to be, that's where you'll find all your variable information, and we'll go through that as we're doing our case study, if you want to call it that. So we'll reference some of those paragraphs, but then that also gets you into a lot of your tables, like your QW 422 is a really good one that has all your materials and your P numbers. Gets you into a lot of your charts with your thickness ranges, your testing, stuff like that. We'll get into that a little bit more as we kind of work our way down. And then beyond that, we're not really going to touch on too much more. QW 500 is all your standard welding procedures. So those are kind of interesting. They're procedures that are just standardized that anybody can use, not necessarily for a code of construction, and we'll get to why later when we get to the registration, but you can actually use those for testing welders, and you'll see that at a lot of test facilities or the union halls, places like that only test welders. They don't go out and fabricate things. They'll use a lot of those, or they'll use the company's welding procedure if you're sending somebody there to get tested. So that's where you'll see a lot of those. And then I kind of mentioned quickly earlier, there's the brazing, the plastic fusion. We're not going to really touch on that. There's a bunch of appendixes, figures and tables in the back, some forms you'll find. I think it's the AB 176 is like the ABSA form for like the welder testing. I believe it's a QW 484. I think is what ASME calls it. So that's what you'll find like in section 9. So they're kind of like a rip off of each other. So that kind of information, there'll be like PQR templates, all that kind of good stuff. One interesting list that there is in the appendices, if your QW422 has all your material specifications in numerical order, and then it'll have a corresponding P number and UNS and a bunch of other stuff too. If for some reason you have a P number and you want to know what material specification that is, there is a reversed index in the back. It's kind of interesting. I haven't really needed to use that too much myself, other than, you know, if you hear a P number, you're trying to figure out what that would be, like an unusual P number you're not familiar with. But there is that reverse index in the back. Just kind of an interesting thing to point out.
Before Google existed, right?
yeah, much before that.
No, that's good. Scott, maybe correct me if I'm wrong. Some of those standard welding procedures that are just there for use that you were mentioning, that's a lot of the union halls and stuff use. Those, if I'm wrong, I think those come from AWS, do they not?
Yeah, I believe AWS put those together, and I think you can, I forget how this works now, but I believe you can purchase them from them. Some of them may even be free. They're really inexpensive if you do have to purchase them. But really the only use, at least around here, it would be for testing. Like I say, a test facility, if you're sending people to a test facility because you're not set up yourself, we have a testing program we have to run through apps on that. I don't know if we'll have time to get into that this episode, but anyways, say you don't have your own testing facility or program, you would send a bunch of your guys to a test center, and you would send them the procedures you want them tested to, and they would test them, send it back with tickets. If a welder wanted to go there themselves to get tested up to try to get a job or something like that, they can walk in there and do a test, and the test facility would use most likely one of these standard welding procedures, because they're not going to put up the cost of developing procedure, getting it tested. You're talking $10,000+ for something that doesn't generate them a lot of revenue. So it's a lot more efficient for them to go with these standard welding procedures. Now, if you get into the super exotic stuff, they don't exist for those. So you are limited to, you know, your stainless steels is about as exotic as it gets. Might get into the nickels, I can't remember exactly, but it doesn't get too crazy. So usually with those scenarios, you're working for somebody already, and they need you to get tested for that. But yeah, that's kind of how those work, and that's where you'll see those at test facilities.
Yeah, cool. Okay, I guess we're gonna kick it off on variables. Or did I already jump the gun?
No, I think that's good. Before we get into our what did we choose here? SMA, so QW253. Before we get into that, let's just explain the variables, 3 of them, what they are, kind of how they apply, when they don't apply. I think that's a good thing to try to clear up, especially the supplementary. I think that's I don't want to say people don't know what it is. Maybe they don't, but maybe it's confusing about when it applies, when that X in that column means something.
No, for sure. So obviously your essential variables are the essential variables required to complete your recipe or your steps to follow to bake that cake or your weld. And those have to be adhered to in order to create a, you know, air quotes, you know, sound weld metal deposit, or is that
pretty good?
Yeah. Sounds like I know what I'm talking about. You'll find out soon in this episode why I roped Scott into doing a podcast, and he's really going to shine. So this is going to be really good. But your essential variables are what you have to follow. There's no if, ands, or buts about it. Those items in that column have to be adhered to, and your welders performing the welding have to adhere to those, I don't want to say variables, but those parameters to complete the weld as it was tested to ensure that it meets the code requirements.
Yeah, that's a good way of putting it. A variable's not always going to be like a single value. It's usually going to be a range, and we'll explain that better as we go through our 253 example here. But that's exactly it. You know, if your recipe says to use 2 eggs, you don't use 1 or something like that, right? To go back to the cake example, but that's exactly it. Everything that's an essential variable has to be applied, has to be followed, or if it doesn't, or if you want to, let's say you have your procedure already and you want to change one of those essential variables, you have to requalify that procedure again. Let's put it that way. So that's the essential variables. That's pretty easy to remember. Everybody knows what essential means. So those are things that you have to do. You can't step outside those ranges. Otherwise, you got to requalify. If you do, there's a chance you're not going to meet the intent of that welding procedure. It might not be mechanically sound anymore. So it's important to think about the welding procedures as the mechanical integrity. That's the only thought here, really. I think I mentioned that earlier, but and you'll see why as we go through our example here. So supplementary essential variables. What is that? That's probably the one people get most hung up with. Non-essential, that's kind of self-explanatory as well. We'll get to that. But the supplementary, why is it supplementary? When does it become essential? What exactly does that mean?
I think the code kind of states it that a supplementary essential variable becomes essential when it can affect the toughness of the weld, correct?
Yeah, exactly. So it's any of your impact tested stuff. So if you're doing, it can be new construction or repair, whatever you're doing, but if you're welding on something that requires an impact tested welding procedure, and we'll get into the minimum testing that's required in a bit as we go here, but impact testing is not required to qualify a procedure to ASME Section 9. That's going to be a specific design, I guess, is that a good way to put it? So if you need to weld on something low temperature and it has to have proven impact properties, that's when you have to do that additional testing. So it's not a minimum requirement you need to do to get a procedure qualified to Section 9, but it is a supplementary requirement that you can throw on.
Maybe we could put it like this. Instead of saying, maybe on your essential variables, it says you need 2 eggs to bake this cake. If you want to chuck in a 3rd egg, you might need to add the following additional steps to ensure your cake still turns out the way you want it. So if you're going to add a different variable into that recipe, you're going to need to follow a couple other steps to ensure that you still get the same type of quality that you need out of that weld as the essential stuff. I kind of fell off there, but I think I got my point across.
It was a good start there, though. That was good. And I think this will make sense as we go through our table QW 253 here, and we'll just kind of explain which ones are checked off. But yeah, that's essentially it. If your welding procedure is impact tested, that's great. More importantly, if you need it to be impact tested for what you're applying it to, then you definitely want to make sure it meets all these supplementary essential requirements. Now, third on the variables is non-essential, and that's exactly what it sounds like. It's how do we say this? It's information, it's things you have to follow, but you can actually make changes to them. So as we go through this, actually the very first section, the joints, they're all non-essential. So we'll explain that here, but it's essentially that.
So maybe a non-essential variable would be something that you could change, which doesn't require the weld procedure to be requalified. Right.
That's almost like it was right out of the book. Exactly that. It's a range of variables, but you can manipulate them. Yeah, that's a good way of putting it. I think the joints will be a good example of that. Before we jump right into that, all these variables are defined. So in your QW 250 is kind of your variables section. So that's going to start with a couple paragraphs of fluff and some information. I think 251 right away lays out your variables and kind of has some definitions, explains them. And then once you get into, like, I don't know if SMA is the first one or not, but it's got to be close to. QW 253 is SMA, the one we chose to just go through. Now those are all charts, and they have all your variables listed out, and then they have columns telling you if they're essential, supplementary, or non-essential. So having said that, I think we can jump into this one here. And we do have a table in front of us just so we can go through these steps. Now, I should say a good way to review a procedure, and why I have this table in front of me, is, for example, you have a small welding procedure and you want to review it for Section 9 compliance. So you got your welding procedure in front of you. Print off this table. It's a one-page table now for the most part. Some of them are longer, some of the other processes. But anyways, so you take this table, start right at the top, and just work all your way down. So the very first one, we got here joints, QW402. And then the next column over, it's got some decimal points. So 0.1, 0.4, 10, and 11. So QW402, if you remember from the beginning when we kind of explained how the book is laid out, so that 400 is going to be all your variable information. It's going to have a lot of your tables, charts, that type of stuff. So what you do, and if you have this electronically, it's even easier. You just click on the hyperlink and it takes you right to it. So you go to paragraph QW402, scroll down to 0.1, and we're looking at the first one, groove design, for example. So, and there's some nomenclature here too, I should point out. So if you have like the circle with the line through it, that means a change. It should have that. Yeah, it does. So down at the bottom, it'll explain what all these things are: plus, minus, up, down, greater than, less than. Some of those are pretty easy to understand. Circle with a line through it means a change. So any change to a groove design, non-essential. So typically what you'll see on a welding procedure, page 3 or 4, or wherever it is, they'll have like a full page of like every random joint configuration you can think of. And that's why they throw that all on there. So then there's no kind of discrepancy. They can do all of these and don't have to requalify their procedure. And even to some extent, if they were going to use one that wasn't on there, it wouldn't really matter because it's a non-essential variable anyways.
Yeah, well, it's the design of the groove. The whole point of a weld is to fill a void and make it a cohesive one piece of material. So it doesn't really matter kind of what your groove looks like. It might affect your weld. Might affect the weld depending on the welder's skill. Now I'm going to see this. It's going to be tricky to talk about, but like your joint design is going to be a joint regardless. It's not. There is parameters, maybe some tolerances on stuff like that, but that's going to fall under the actual construction code and not within section 9. The groove is the groove, and you're just going to have to fill it and weld it and fuse it.
Right, and I think the important takeaway there is groove design. So there's specific designs you can use, like double bevel, single V, double V, J groove, these type of things. These are design joints. It's not like you're just putting 2 square ends together on a 1-inch thick piece. It's not something like that. It's a design joint. So that's kind of why they have all of those laid out there, so that the welder has a bunch of different options, or I guess it'd be the pipe fitter at that point, of what they can use. I don't know if we got to go through every line on the joints. Backing. So anytime you remove backing, these are all non-essential. So root spacing, retainers. I don't think we're going to get too into that. So unless you have a point you want to make on any of the joint stuff, Frank, I say we could move on to base metals.
Yeah, I think, essentially all the joint stuff is non-essential. And we can jump right into kind of the base metal stuff where we have our first essential variable, and that is the thickness qualified, right?
Yeah, I guess really quickly, this popped in my head for the joint stuff. Just make sure you're following what your WPS has laid out. Keep in mind, those are non-essential, so you could add something from this section to your WPS without requalifying it and just kind of reissue it. But all that information will be on your WPS to follow. Like backing is a good one. It's not essential, but it is going to be listed out as, with or without backing, or it's going to be like with backing, weld metal backing, something to that extent. So just make sure you're following what your WPS has laid out for you. And if you do want to make changes or add something there, you can without having to officially requalify it. So all I really want to say about that. Yeah, so base metals, like you said, Frank, we're into the supplementary stuff. So now we're getting scary.
So I guess the first kind of supplementary essential thing would be your group number. Right. So like we kind of alluded to a couple minutes ago, depending on your material and your client specifications, you may or may not require impact testing. So supplementary essential is just that. So if your client requires this to be toughness tested or Sharpie impact tested or something, that might be something that you may need to requalify that procedure for if the client wants it, or if you're doing some work that requires that type of testing. Yeah,
and just keep in mind with that, that is a supplementary variables. So if you have a procedure that's not impact tested, it's going to have like P1, group 1 and 2. It's going to be qualified for both. And it may be for both if it's impact tested too. In that case, you want to look at the PQR and make sure that they use one of each to get both grades. This is kind of an example. P5B used to be an interesting one where they had the different group numbers. They've kind of got rid of that now. I think we'll get into that a bit later too with the postal heat treat. That's just something that I think they've made more confusing. But anyways, that's something to be aware of. A lot of times you'll have a procedure that just says P1 to P1. Just be aware that there is group numbers there that can come into play when we're talking about impact testing.
No, good point. So maybe one other point to think of when we said that for our joints where it says backing may be non-essential, that's for the procedure qualification and not for the welder qualification, right?
Yeah, good point.
So your welder may only be able to weld with a backing. We're going to get into this a little bit more. We've honestly spent probably an hour and a half, 2 hours just trying to figure out how to do this. And it seems like now that we hit record, like this, we're sweating bullets and trying to, we're all over the map, but it'll all come together. Trust me. So
I think it's just hard to piece it together. I think we'll try to throw some examples of like the differences between the procedure and the welder, but don't forget the welder is like, that's its own conversation as well too. So we'll see how this goes. Maybe we'll lead into that, but I think you'll find us chucking some examples in there about some of the differences. And I think that's just a good way to explain it.
Yeah, you're going to be testing the cook with that one and not the cake recipe, right?
That's right. Somebody's got to bake the cake now.
Okay, so we left off at our first supplementary essential there, which was the group number. Our next one is going to be the thickness limits for toughness. And then we come up to our first essential, which is going to be our thickness qualified. So that procedure is going to be, the welding procedure is going to be qualified to a specific thickness range, right?
Yeah, that's right. What else do we have in this section? Just see what I want to do with this. Let's group these two together. We got T limits for toughness and then thickness qualified. So that's just two things to be aware of. There's a chart that'll give you tensiles and the thicknesses you get. I think it's 453. I do have it here. Let me just check and see if I'm right. 451, sorry. So that's gonna, what were we talking about here again? Thickness qualified. Okay. Yeah. So so 451 is going to give you the testing that's required, and I think we'll get into this a little more detail as we go, but it's going to give you your thickness ranges. So where this would come into play, if your procedure is qualified to 3/4 of an inch max and you needed to weld something 1 inch, obviously you're not qualified. You can't extend that range without requalifying the procedure. So in that case, you're going to have to do another recipe, another PQR to get that cake a little bigger in this case.
Yeah, you're adding another layer to the cake, so to speak.
Yeah, there we go. We're going 2-layer cake to 3-layer cake. Same thing with the T limits, thickness limits for your toughness. And that specifically, when we get to the code review section, 31.3's got some interesting, more stringent requirements on that. So just be aware of that too as well. There'll be some ranges that you get qualified for based on the thickness of your PQR. So for example, if this isn't coming out very clear, you can just go to your 451 table. Let's say we have a test piece. So it'll give you your thickness range of your test piece. So let's just pick 3/4 to 1.5 inches for an example. So you got like a 1 inch test piece. That will give you 3/16 to 2 times T, so 2 inches in this case because we use the 1 inch test piece. So that's how you calculate the ranges you're going to get, and that's kind of why you're most likely going to see a WPS with several supporting PQRs. It's not too often there'll be one, because if there's only one, the first thing it's going to be very limited in is the thickness, because every PQR thickness is only good for a certain range of qualified thickness. And I know maybe a very limited procedure is just fine for them. Like owner-user companies could have limited procedures because they only use it for certain things, and that may be fine, but that's something to watch out for. Your thickness range has a min and a max, and you can't extend or reduce that. You have to requalify that, hence the essential.
Kind of makes sense. I'm already starting to go cross-eyed, I think.
It's very hard to explain this and make it simple. I find
you need an overhead projector, right? You need people following along with the charts.
Yeah, almost. It's a very easy thing to follow and to understand, but not if you don't understand it, obviously.
Why don't we take a quick step back here and gather some thoughts?
Well, remember at this point, we're just doing the Section 9 review too. After this, we'll get to the code of construction and kind of show how that's different. So really all you're looking for here, let's say you look at the cover of the welding procedure and it's got a thickness range. Let's say it's maxed out, 1/16 to 8 inches. They're likely going to have quite a few PQRs there. They'll all be listed on the front. The numbers, whatever they've named them. You flip to the back and go through them all. There should be quite a range of thicknesses. There's probably be a 16th, there'll be a 1/2 inch, probably be a 3/4 inch in there. And that's going to give you a certain range. So a good way to go about this review, go to the PQR, check the thickness, go to your 451 table, write down the minimum and max you get from that, and do that for each one, and then just see what you have for a range and make sure what they've qualified their WPS to agrees with the recipe or their PQR. And this is a Section 9. This is all we're talking about right now. Later, we'll get into applying that to your construction or your repair.
Okay.
Make sense?
Yes.
So at this point, we're just verifying that they've said it's qualified to Section 9. This is how you make sure it is. So that's all we're doing at this point. So I think we're as clear or as confusing as we can get with base metal thickness. So there's thickness of passes greater than 1/2 inch. That's an essential variable. I don't want to get into that one too much. Let's talk about the P numbers qualified. That's the next one. So 403.11. That's an essential variable. So where you'll get your P number from. So say you used, we'll just use P1 as an example. So like a carbon steel. So you used most likely plate, and we'll get into that, why it's plate and not pipe when we get to positions and whatnot. But so we use some 516-70 grade plate. You can go to your QW422. It's quite a lengthy table. It's all in alphanumerical order. Find that specification, scroll across. It'll give you the P number. It's going to be a P1. Now, typically, you're qualified for that P number. Now, there is another table followed right after the 422. I want to say it's like 424. Yeah, 424. I'm pretty sure that's it. And it'll give you a couple of ranges, and I believe it's only up to P4. So for example, you can have like a P1 to P4, and you can interchange a couple of those. Once you get beyond that, it's really quite specific to what P number you can use. So what you're going to do is just go to your 403.11 and see what kind of ranges it gives you. If it's a P1 to P1 procedure, you'll be fine. If you got a procedure that claims it's qualified to several different P numbers, that's something you're really going to want to look into. So I think the biggest takeaway from that is knowing what P number it is. And that's going to be probably more applicable to when we get into a repair or construction. You got to know what material you're welding and what P number that is, and if the procedure that's presented to you applies properly to that or not. It's hard with the Section 9. There's not a whole lot to say with the P number, but that's going to become really important when we start applying it to the material. I don't know if I got much more to say other than that. The 422, that's where you find your materials and your P number. And then don't forget the 424 gives you a couple different combinations you can use. So basically how that one's laid out is it'll say P number welded, and it'll have 1 to whatever listed, and then the other column will say welded to, and then it'll give you what you're qualified for. In some instances, it's only going to be one of those. It's going to be this one and the one it was welded to. And in the case of like 1, 2, 3, and 4, it gives you a range of a couple of those. But beyond that, like I said, it's going to be pretty specific. And remember, we're talking mechanical integrity as a way to think of the welding procedure. So if you start messing around with the base material, obviously those properties change a lot. So that's why you have to requalify it. You can't assume that, let's say you welded a carbon steel plate together with 7018. You can't assume that you can just take some 9 chrome plate and weld that together with a different consumable, and just because the first one worked out, this one's going to work out too without testing it. You can't assume that. You have to know the mechanical integrity by doing the destructive testing.
Well, even those materials and they'll have different weldability characteristics, and even the filler metal, anybody who's welded 7018 and then like a 316, like that rod burns totally different, and it's going to have totally different characteristics while you're welding it, which will affect your final product.
Yeah,
right?
And that's
the final outcome. A
big thing with that too, with the welder testing, is where that comes in. And if we get time to talk about that, we'll get into that. And it's exactly that. It's a weldability standpoint and kind of a skill thing. Whereas the WPS is, the finished product and the mechanical integrity that gives you, and then just proving that. Where are we at here? So P numbers. So I think we're okay with that. Frank, you already jumped into fillers. So why don't we get to F numbers? So this section is going to be all on filler metals. So maybe we should explain quickly. So the P number, I think by my rambling, everybody gathered that is the base metal. So the P number is the designation that ASME gives listed specifications. So like the 516-70, like I gave, for example, is a P1. Now, another thing to consider with that, unlisted material that doesn't have an assigned P number is only qualified to that specific unlisted material. So if you've got 2 strange metallurgy materials, or just something that's not listed with ASME, so it doesn't have an SA designation, and you don't find it on QW422, that procedure is going to be, it's not going to have a P number, it's going to have unlisted, and it's just going to have that specification. So that's going to be something very specific, and it's likely going to be a job-specific thing you ran into. Now, F numbers, Frank, you already got into talking about the filler metals. So that's exactly what the F numbers are. So it's the same idea too. ASME gives all the filler metals based on their designation and F number. And there's a table very similar to 424, QW432. So that is essentially the same thing. You can run through and find your consumable or your F number, and you can cross-reference it. And that's basically how you can tell what you're qualified for. So if you're looking for, let's use something that's specific, like an F5, that's going to be like a stainless steel small consumable. So that procedure, we're going to be qualified for like a P8, so that would be stainless base material, F5, stainless small consumable. Now, where this gets interesting is F6, where that can be a TIG consumable, that can be some of your wire feeds, and then it doesn't differentiate when you go from carbon steel to stainless steel and things of that nature. So that's where you got to be very careful with the consumables. Getting a little off topic of our P1 procedure we're trying to review here. A good example of this is stainless steel, like I alluded to. A lot of times you'll get a procedure that will be P8 based material, so stainless steel, and then it'll have your F6, F5, or maybe just F5. But then all the designations, they'll have just all the 300s, like 3XX. So it's actually qualified to use like a 308, a 309, 316, 347, a whole range of things. So that's where when we get to our code review, client specs section, we'll talk a little bit more to that. But really for the ASME Section 9 review portion, you can just see the material specification they used. You can cross-reference that F number and make sure that that's the correct F number that they've qualified this procedure to. I think that's all we can really say about it at the Section 9 portion. What do you have to say about that, Frank? Does that make sense?
Fuck. You're spitting numbers out like crazy, dude.
Are they right? You're supposed to be fact checking me.
Jesus.
So A numbers, basically when your F number is a liquid and it becomes a solid, it becomes an A number. That's one way to think of it. Essentially your A number, a lot of times this isn't used either because it's going to be restricted to ferrous materials. When you get into the heavy alloys, there's so much different flavors is a word I like to use of the chemistry you're going to have. So they just kind of stop designating them at that point. So it's restricted to the ferrous numbers, and what it is the chemical composition of your weld metal. So there is a paragraph. Sorry, there's always a paragraph 404.5. But there's a chart with your variables and what ranges you can be qualified based on what A number you've achieved, or a better way to say it is it'll give you an A number for the consumable. So I believe the carbon steel is A1. So you're going to have you could potentially have an F3, F4 welding procedure. So that would be 60-10, 70-18. It's going to be qualified to P1 to P1. So that'll be your carbon steel, like your 516 grade 70. And it'll be qualified for an A1. And that is an essential variable. And I believe that was the last one in this section. Maybe not. Make sense, Frank?
Yeah.
I think at this point, I'll say I've been rattling off some table numbers, and maybe you're wondering where I'm getting those from. I know Frank is, so maybe we should have explained this before we started going through it. So like we said at the beginning, the first column there has your paragraph. So we're in the filler metals. Let's stick with that. So QW 400. So that is going to be a number of paragraphs that has all your information related to filler metals in some way. Let's go with one that has a table. So let's go with the first one, the F numbers. So if you want to know, and that's an essential variable. So if you want to know the essential variables for your F numbers, you go to QW 404.4. It's going to give you a bit of information, and what it's also going to do is going to reference you to QW 432. Now that is a table that has all your consumable designations and what F number they are. So that is actually what gives you your range. So you can, based on what consumable you're using, your 7018, it's going to tell you that that's an F4. So you can qualify your procedure to that specific F number, F4 in this case. Same thing with like backing it up again, like the P numbers. So that was a 403.11 was the P number variables. So you go to that paragraph, it's going to give you some information on your variable, and it's going to reference you to QW 422 to find your P number. And it's also going to give you a list of ranges qualified, which would be your 424. So that's going to be a shorter table following the 422. And that'll be, like I explained earlier, it'll have some combinations of welding procedures. It'll have combinations of P numbers welded to another specific P number. And it'll give you the range you can qualify to. Most of the time it's going to be to itself, to that P number in itself, or in the case of P1 to 4, it's going to give you a couple of choices there. But it's usually specific to the P number. So that's kind of where that comes from. I hope that's cleared that up a bit. We'll keep cruising through this. A number we talked about only really applies to the ferrous material. QW 404.6. So that's diameter. Now we are talking about filler metals now, getting back to where we left off. So not base metal diameter. So we're talking about filler metal diameters. that is a non-essential variable. So you can make all kind of changes to that without having to requalify. Now, what you have to watch out for is the very next one. So 404.7. So that's a change in a diameter over a 1/4 inch. Now that is back to our supplementary essential variables. So if you have an impact tested welding procedure and you want to have it qualified with 1/2 inch rod or something more than a 1/4 inch for whatever reason, you have to actually do a PQR with that diameter. So it's a little bit of a restriction there with the supplementary essential. And for anybody that understands metallurgy at all, that does make sense because your heat input is going to be quite a lot different when you get to a consumable that large. And I believe it does give you a little out that if it's post-weld heat treated, it may not apply. You definitely want to check that though. So 404.7. Cruising along to the next one here, 404.12. So that's the classification. Now that is again a supplementary essential. So what that means is like the SFA numbers, the trade names. You can change out consumables within the same SFA, but if you start changing those around, even though you're in the same F number, if it's an impact tested welding procedure, you're going to have to requalify. So something to watch out for there. What I've ran into a couple times with this in the past is with subarc and specifically with alloys. So when you get like, and now that'll be a different table here. We're looking at 253 subarc is going to be a different one. But I've seen where the trade name actually came back to haunt us, and it was actually quite difficult to find that trade name of consumable, or maybe it was even the flux. I can't remember, but so that does come into play sometimes. So it's just something to be careful of.
Yeah, it gets pretty confusing.
Oh, okay, where are we at here?
Filament, did we cover thickness?
Yeah, so that's where we're at now, right? 404.30.
Yep.
So that's an essential variable too. So think of that as the same way you would think about your base metal thickness. You can't just extend that thickness range. If you're going to beyond what 451 allows, then you're going to have to retest and requalify. I think once we get through our QW 253 table here, we'll talk about some of the testing that's required and how that works with the table 451. But that is going to kick you to that table as well, similar to 403.11 did. That's going to kick you to, no, sorry, that's the P number. The thickness qualified 403.8. So that's going to reference you to the 451 as well. And that's where it's got all your testing laid out, your thickness ranges that you get qualified, as I alluded to earlier. So we'll get into that one a little bit more once we get through this. And then the last one is just a change of classification is not essential. So remember we alluded to earlier that a change in classification is supplementary essential. So that's if you're changing SFAs, trade names, things like that. If it's not impact tested, provided the F number is the same, it can be a different SFA number and you don't have to requalify per se. So positions be the next thing. So QW 405 is we're going to find all this good information. I think this is a good opportunity to talk about, there's only 2 points here, point 1 and point 3. It's addition of a position and a change from vertical up to vertical down. I think this is a good time to talk about the difference between the welder testing and the procedure testing, or welder performance testing, welder procedure qualification. You just got to be really careful of those two things. Now, these are both non-essential, interesting enough. So, Frank, if you weld a piece of plate in the flat position, 1G, is your welding procedure qualified for all positions?
Yeah, because it doesn't matter what which position you're testing the weld to. It's going to be your welder's performance that you want to test in the positions.
Yeah, exactly right. And that goes back to what we were saying at the start. You got to think about this, how the mechanical engineers that put this book together were thinking about it. You're testing the integrity of that base metal and that weld metal. Now, putting it in with the proper skill and following the PQR, that has nothing to do with building the PQR itself. That's where the welder testing is going to come in. So that's why the welders have to get tested in various different positions, and it's more stringent for them because that's more of a skill. Now, the PQR is taking into assumption that whatever position you've done this in, it's in there mechanically sound and followed all the other parameters, and now we're going to rip it apart and verify that what we've done works, right? It's mechanically sound. Our cake's what it looks like, what it's supposed to.
You want to make sure it tastes like it should.
There we go. Buttercream.
Yeah.
And then same with the welding, switching from vertical up to vertical down. Interesting one there too for you pipeliners, right? You can go with downhand with your welding procedure. You don't have to requalify it. Now, the welders most definitely do, unless oh man, we'd have to look this one up. But I believe they have an out, like if I think the cap pass can be done in the downhand position without the welders having to requalify. And also I believe the root can be put in as long as it's back gouged out. There's a couple outs there, but for the most part, if your welder is going to be welding downhand, they're going to have a downhand ticket. Now, if you're going to change your welding procedure, you can do that without actually requalifying it. But that is something you're going to want to specify in your procedure. So if your procedure is written vertical up progression, that's what you're going to do. If you want it to be both or to be downhand, you're going to have to redo that procedure, but you don't necessarily have to requalify it and resubmit and re-register and all that good stuff. And we'll get to that as we go along here. But I think that's a good example of the difference between the procedure qualification and the performance qualification.
Yeah, because usually when they're testing the weld to ensure that the welding procedure works, they want to do it as in ideal conditions as possible, and doing it in the flat position is usually the most ideal position. It's when you're testing the welder, you want to ensure that they can still deposit that metal in whatever position is required, and whichever progression, I guess, vertical or downhand is going to be, whether they're capable of doing that.
Yeah, exactly. I mean, you want to avoid sending the stuff to the lab multiple times for failed tensiles or toughness, if that's something you're dealing with. So yeah, you want to do it in the easiest, best chance for success you can, and you still get a full range of positions. So yeah, why wouldn't you do it like that? And then that's where your welder testing comes in hand. So the welders take care of the all position, the welding procedure takes care of the mechanical integrity. So if the welder is competent and has the skill to do it in any position, and we've tested our procedure with that consumable and all the other variables, we should be good to go.
So Scott, why do you think that a supplementary essential variable would be as if you increase the preheat temperature? Oh, sorry, I'm jumping down to preheat.
No, that's good. That's the next section we're at, UW406. So yeah, kidded.
So why, if we increased it by 100 degrees, do you think what would change the toughness there?
Well, again, that just kind of goes back to the heat input, right? That's what they're alluding to. So you got to think of the mechanical integrity. It's kind of along the lines of the large diameter consumable. You're going to have a lot more heat input there, so therefore you're going to have a lot more or less toughness properties. Same thing with the preheat. The best way to slow cool a weld, if you will, is to preheat it or to apply a preheat. So that's going to affect the impact properties. So again, if you're an impact tested welding procedure and it has a specified preheat, you got to stay within 100 degrees of that. If you want to crank it up to say a good example is like P1, when you're into the really thick material and you're not post-hole heat treating it. It is exempt, and we'll get to this when we get to the code section, but you do have to apply a pretty high preheat, like 200 degrees. So if you have an impact tested procedure and it's only 50 or 70 degrees specified preheat, you got to just watch out what you're doing there.
Yeah, no, okay, fair enough. Do we need to do anything else on the preheat here? We can jump right to post-weld.
Yeah, I don't know if there's a lot to say about that. Yeah, there's a decrease limit there. There's a preheat maintenance, and then like you talked about, the increasing. That's fine. Let's get into the postal heat treat, QW407. So what is the first one? There's an essential variable, and that'll be a change to the postal heat treat. And then the only other one is supplementary, and that'll be a change to the time and temperature range. So interesting with that one, it's a supplementary essential, not an essential. So if you're if you have a non-impact tested welding procedure, your time and temperature is, I don't want to say unlimited, but it's got quite a range to it. And you can really increase or decrease that as much as you want. Now, something to be careful with that is, and we'll get to it, is the code of construction, which has something to say about that, but more specifically your client specs. But for the Section 9 portion of it, it's interesting, you got quite a range there. And then again, supplementary, so that's something that's going to affect your impact properties. So going back to the first one, a change to the postal heat treat, if you go to that paragraph 407.1, it's going to give you some things like postal heat treat above the upper transition temperature, below the lower transition temperature. It's going to give you a couple of things like that, and that's what they mean by changing the postal heat treat. So like your carbon steel, it's going to be, 1200, somewhere in that range. If you want to heat treat that thing over the upper transition, so into the 1400s for some reason, which isn't a good idea to do that to that material, but if you needed to do that, you would have to requalify that. That's kind of what they're getting at there. But yeah, just go to your QW47.1 and it'll step out a couple scenarios there.
No, the time and temperature is definitely going to affect the quality of your weld and even its properties for service and whatever else, right? It's going to make it more susceptible to damage mechanisms or service damage mechanisms or corrosion, and even just mechanical properties such as impact properties.
Well, really, the only thing Section 9 is worried about is the impact properties because it's supplementary. So it's a bit of an interesting one, and we got some good examples when we get to the client spec stuff where you really got to watch this. Just because code says something or the procedure is qualified to something, specifically to postal heat treat time and temperature, doesn't mean that's the best application for the material. So we'll save that little gem for later. But yeah, kind of some interesting takes on post weld. If it's impact tested, you really want to be aware of that time and temperature. And then if it's not, you're kind of not unlimited, but you got quite a range there. And then again, it's the upper transition temperatures and things like that they're worried about with the 407. And rightly so, right? You go through a lot of phase changes and stuff there. We won't get too deep into that.
Oh, that was the worst part. I hated that. Oh, fuck.
What is the old iron carbide diagram there?
Oh, body-centered cube, face-centered cube, and transition temperatures. Like,
love it.
I get it, but I also don't get it. Like it's.
Oh, that's a career path of its own too, right?
Oh, man.
Like a lot of sites I've been to, and I've seen like all different where like, the junior owner inspector guy that doesn't really know quite what he's doing yet is approving welding procedures. And then there's other sites where the only person that can approve them is a welding engineer, and there might only be one on site. So everybody kind of has their own take on these. That might be a little extreme, but you definitely want to have somebody that's pretty knowledgeable approving these things. Having the junior guy do it's probably not a good idea either. But anyways, moving along, QW409, I don't know if we want to talk about this too much. Heat input is a supplementary essential. We've kind of been talking about that all along. Current and polarity, yeah. Voltage and amperage range, yeah, that's non-essential. Very interesting stuff there if you want to read up on it.
Yeah.
Technique, so this will be our last section here of this review anyways. So QW410, stringer and weave, this one's interesting. Most of this stuff is not essential, but this is where I like this one. You'll get some of the older welders doing the old Texas weave on there, and you're in position or something. So they obviously used a 1/8 or something like that, or 5/32, and you go asking them, well, why are you doing such a wide weave here? This is against the procedure. And well, show me where it says this. Now, they might not know that it's a non-essential variable. However, your procedure is most likely going to have listed stringer or weave, and then it's going to have like 3 times the electrode diameter. So that's right on the procedure where you can show them, hey, look, this is welding procedure is specified 3 times that diameter. If you're using 1/8, that's a 3/8 weave. Sorry. Grind that off and try again. There's a couple other things here. Method of cleaning, I'm not going to get into that. Back gouging, don't really need to get into that. Single to multi-pass is a supplementary variable. Manual, automatic. Peening, addition or removal, oddly enough, is a non-essential variable. Now that's something where you're going to really, I don't know why somebody would have that on too many welding procedures, but that's something when you get into your client specs, you're going to really want to be careful of. You're not, in some services, you're not going to want to see a procedure that allows for peening. And then just I think Frank had something to say about that, but just the thermal processes. So that's like your back gouging and things like that. That is an essential variable. So that's why you'll typically see on most procedures, they'll have listed, usually in the repair section, they'll have like grind or back gouge to sound metal, and they'll kind of list a couple of different ways to grind or gouge out the material, and that's why. So those are all the things you can do if you're if that's not listed, and specifically with like stainless or chromes or things like that, then you're going to have to requalify again just to include that.
I was just going to say peening before I was choking on my own saliva there. Peening is like such an old school thing. Can you think of any cases where we apply that in our modern age?
Modern age. I don't know. Like on the farm, we do that sometimes, welding cast iron parts together. So there's kind of a couple ways you can weld cast. I don't know if I want to go on about this too much, but one way to do it is to heat it up. Now, cast iron has a lot of carbon in it. That's why it's difficult to weld. Mm-hmm. Not recommended to even weld, really. So you can heat it up to a really high preheat and keep it hot the whole time, the whole welding process. You can weld it and then wrap it and really let it slow cool, like almost like a chrome or something like that. Another way you can do it too is you do it cold with no preheat, a little bit of bevel prep on the crack or whatever you're trying to fix. You weld a little spot like an inch and peen the weld quickly before it has the time to solidify while it's still plastic, so you can mash it around, and that's supposed to help it from cracking and that. That's about it. I mean, in refineries and stuff, I can't say I've came across anything like that where we've wanted to do that intentionally.
Actually, in a meeting the other day, we were talking about welding cast iron, and I think it was on a pump body. Yeah, or something like that. Yeah. That's where you're going to run into it. But normally, you're right, you don't run into it, and it is extremely difficult to weld. So far and few between. Yeah. So that was our QW253 SMAW review. That was Scott's run through of it. I was trying to just hang on to the back of his coattail there and ride it.
I think the big takeaway from this is the best way to review a procedure for Section 9 is to print off the table of variables that's applicable. So we went with 253 for SMAW, just for an example. Whatever process you're using, you're going to want to follow. Print that table off, have your procedure with you, go to the paragraph it references, and then if it has a reference table for your variables, that's where you go to that table. So all those tables I was rattling off, that's where those come from. If you're wondering why you don't see them on this QW250, whatever it is you're using table, it's because they're not there. They're in the referencing paragraph. So that's where those come from. Do you want to talk about before we jump out of this, still on the topic of these essential variables, the variable tables, not just essential. So there's also hard surfacing, corrosion resistant overlay, and temper bead. So what I've I think this was a 2019 change. Maybe it was the year edition before. But anyways, what they've done is for the process, 253 is our example. The next page, you have 253.1, which is almost like an add-on to the table. And that'll have your hard surfacing and your corrosion overlay. And then it has your all your variables listed out there. So you just do the same thing. You go through them all, go to the referencing paragraph, and it is laid out similar, but not exactly the same. So it has your essential variables, and then it has split between the hard surfacing and the corrosion overlay, and then it's got your non-essential, which is the same for both, being non-essential.
Yeah, pretty much the same. Actually, Scott, I have the 2017 version in front of me, and it is in here. So
okay, yeah. So
might have switched over then.
That might have been the year. They change these around a bit. It's kind of nice now. It used to be like later on, in the chapter or in the article, if you want to call it. So you kind of had to flip through a bit to find it. I believe the temper bead is still a standalone, but it's going to be in with these 250s too. You just got to keep going until you get to it. What else do we want to say about this? One point I wanted to make without getting into too much is tube to tube sheet welding procedures. Now, this is something to be careful about as well. If you're doing strength welding on your tube to tube sheet, and that'll be called out for in your code of construction. Maybe we should leave this for the code of construction review, but maybe we can talk about it more then too. But anyways, all I really want to say about that is it has its own set of variables as well. QW288, so that's its own table. So you just keep going. Once you get through all these 250s and you keep going, it's in the 200 section. You'll get two variables for tube to tube sheet welding, and keep in mind that's for your strength welding when designated by the code of construction or the design code. Good example will be section 8. So you will have to do a mock-up PQR for those specific procedures in some instances. Now, if you're just doing seal welding, or say you have rolled tubes that are leaking and you're doing a seal weld repair in the field, that's not necessarily a strength weld. So your procedure that we just reviewed, that was a piece of plate, section 9 review we did, that's most likely going to be just fine. It's your strength welding, and you just have to know when that's applied and when it's not. Your design drawings are going to spell that out. Your code of construction will. So just be aware of that. If you're into the strength welding, it's a whole new set of variables, and you're going to have a whole separate welding procedure, a separate PQR, totally different mock-up. Just something to be aware of. I don't think we really need to get into it. It's very similar. Joints, base metal, filler metals, positions, that kind of good stuff. But the mock-up's going to be a lot different because it's going to be essentially a fillet weld. It's going to be like a tube to tube sheet mock-up is what you're doing. So just something to be aware of. That's all I want to say about that.
Couldn't have said it better myself.
Where else do we go with this? I think we're going to talk about the charts and the testing a little bit. How about expiry? Does your welding procedure expire every 2 years, like the welder ticket? Does it every code edition? Do you have to renew it?
This was actually something we were talking about before that we found interesting, was that you can actually go back quite a ways with weld procedures that were created using this code. I think all the way back to 1962 is when they I don't want to say first implemented it, but is when this came about. And if you had a qualified welding procedure created in the early 60s there, it's still good to go because it was created in accordance with section 9, right? It's just anything before that, which is even crazier to think that still might be around, is
oh, they wouldn't have been qualifying anything back then. Just get it done.
It was all explosions before that, right? That's why they put this code together. But
yeah,
it's actually pretty neat. So any welding procedure created in accordance with section 9 from 1962 to present is still good to go. You can still weld with it. Shouldn't be any issues.
Yeah, right. I mean, if the recipe makes the cake and you don't change the recipe, what's the problem, right?
Yeah, no, it's still, I don't know. Yeah, it's still going to be good. The only thing that's kind of changed is the processes have gotten probably a little bit more efficient, and the materials have become better over time, right?
Mm-hmm.
So still, a cake's a cake, right? And if you follow all the right ingredients and put everything in where it should go, it should taste the same.
Well, and there's new materials getting added all the time too, and that's what's nice about your 422 and listing your P numbers. So if you have a procedure that was developed for a specific P number and a new material comes along and it happens to be that same P number, it's still qualified to use for that, which is kind of nice. So it's not you don't have to requalify your procedures because the code changed or something like that. When you will have to requalify them, like we went through with our review, is anytime the essentials change, the supplementaries, things like that, you're going to have to requalify, issue revision, resubmit, re-register. And we'll get to that. We got a registration part coming. So that's just kind of another difference between the welders and the welding procedure. The welder tickets do expire because, again, that's a skill you're testing, whereas the welding procedure is just a recipe that you've created at one time, and as long as you follow that recipe, you're going to have the same results. So there's no real reason to requalify that and pay money for it again. It just doesn't make sense, right?
No, it is what it is. That's, you're always testing new chefs with the same old recipes.
Yeah.
You might as well just keep testing the welders to the same old procedures and make sure that they follow them. They've tried, tested, and true anyway.
Yeah, it's exactly it. I think one part, what should we go to first? Some of the charts and the testing.
Oh man, I'm still cross-eyed from you winging through that.
Or let's talk about the PQR. One PQR for multiple WPSs, one WPS for multiple PQRs. What does that mean? Let's do that first, and then we'll make you cross-eyed again with the charts and the testing. So what exactly does that mean? How can one PQR support multiple WPSs? Or let's say several PQRs that we're making one recipe. How can that support multiple WPSs or multiple recipes? Like how would that be a thing?
I think the example we were talking about before we hit record there, Scott, was thickness ranges, where you might want to qualify a bunch of different thickness ranges.
That would be, yes, the one below, one WPS, multiple PQRs.
Multiple PQRs,
right.
Yeah.
How about one PQR, multiple WPSs? So say a couple welding companies wanted to get together and save some money.
Yes. Yeah.
Okay, remember this one? And they hired the welder, the company that developed the procedure for them, does the testing and all that. So what they can do is all get together, each have a representative, have whoever weld up the coupon for them, have all the testing done, and they can actually write a procedure for each company, provided there was a witness there and a couple other caveats. But that's where that comes into play. I don't think we really see that a lot in our industry. We probably see the more of the company takeovers where they actually end up owning the procedures, and we'll get into how that works in the registration. But that's kind of where that would work. Now getting to what you were jumping into, Frank, one WPS with multiple PQRs. When would you see that? You would probably most always see that, but how does that work?
Well, obviously you have a varying amount of materials in different thickness ranges, even just throughout any facility. And sometimes your welding procedure, you're going to have your same kind of materials, but sometimes the thicknesses are going to range, and some of the... I just drew a blank. I just kind of went right sideways there.
Well, back to your 451 table, right? With all the thickness ranges it gives you. You can't get that with one test piece, right? There's no way.
No. That was a really good save. Thank you. No, you're right. So you're going to want to test it to a bunch of different thicknesses. And I think that might... no, I'm not thinking. If I'm thinking, I wouldn't have...
Ended on a high note. But that's exactly it. Whenever you're reviewing a procedure, it's going to have procedure number 1 or whatever it is, and then it's going to have supporting PQRs, and there'll be, probably 2 or 3, sometimes maybe a bunch more. An instance of that would be where they did like 2 or 3 to get a bunch of thickness ranges, and then somewhere along the line they wanted to add impact testing, so they did 2 or 3 more PQRs, because now don't forget impact testing also has its own thickness range too. So you may even see additional PQRs where the only testing done was impact testing, and that's fine. So you can review that, verify its qualified thickness range is good, but don't forget you got to also verify that it had the tensiles and bends done. Maybe that's a good segue into the testing portion, what testing should be done and what's the minimum. What are some of the supplements where you'd find that info? I think that's kind of a good point to talk about next before we get into the code of construction review. 451 we've mentioned a bunch of times. You must know that one by now, Frank. That's the one that gives you all your thickness ranges.
Yeah.
So it'll give you your test, your coupon, your PQR that you welded. It'll give you a range of thicknesses. And I think I gave an example of this earlier, but you would have whatever thickness it is, find the range it fits into, and then it's going to have the min and the max you're qualified for. Now, it also has, that's where you'll find for your filler metal thickness range is also on there as well. And if you were following along in our review before that, we would have referenced you to this table. Now, getting back to the testing, what it also has is the testing requirements to qualify this procedure. So there's a couple of things here. We'll talk about the minimum testing first. So you're going to have tensile tests done, 2 of those, and then you're also going to have either side bends or root and face bends done. Now, if you don't know what those are, you don't know what I'm talking about, tensile, I think anybody listening understands what that means. You basically machine down the area. So you cut a section of the weld out, you taper down where the weld is thin intentionally, so that's where that breaks. You just put it in the machine and you pull it apart, and where it breaks, it measures it in PSI, and it gives you a tensile value. Based on your material, it has to meet a minimum requirement. Now,
that I can't speak. I think I can speak to this.
Okay.
That tension test, the breaking point of that specimen has to match the material specification or be within 5%, correct?
Yep. And you'll find that in your 422, the table we talked about that has your P numbers and everything listed. It'll have UNS numbers. It'll have a lot of information, but it'll also have your minimum yield strength in there.
Yeah, perfect.
And a good PQR with the test from the lab is probably going to list that minimum yield as well, or ultimate tensile strength is probably what they're going to use, and then it'll have what it broke at. So it's pretty easy to compare, but then you're going to want to go back to your 422 just to make sure that they were using the right number. Now, so you're going to have 2 tensiles done. It's a minimum requirement. Now, this information you're going to find in the general section, so the QW 100. So the tensions will be like 150, and it's going to reference you to this table, 451. Another thing you're going to have is some sort of bend test as well. So a side bend is exactly what it sounds like. You cut a section of the weld out and you bend it transversely. So you're bending it sideways. A root and face bend, same thing. You're going to cut a section of the weld, but you're probably going to cut it wider, than your side bend, and you bend it so the face or the cap of the weld is on the outer radius. That would be your face bend. And then the root bend is exactly the opposite of that. You would bend those pieces the other way, so the root is on the outer radius. So you're going to have, there's a couple ways you can go about this, and it is dependent on the thickness of the material, and QW451 is going to explain to you what you have to do or what you can do. You have options based on the thickness. So you can either do 4 side bends. That's going to be for your thicker material. And obviously with that, you can't do a root and a face because you're just creating such a radius that it's not a fair test to it. So that's why you do the side bend. So you can cut it at a controlled thickness, and then you'll do your transverse bend. Now, the thinner stuff, I think they're really thin, like the 16th and under. That's where it's going to specify 2 root and 2 face. And then moving up from that, like over your 16th to 3/4 inch, I think is the limit. It's going to give you the option. You can either do 2 root, 2 face, or alternatively, you can do 4 side bends. So that's kind of the minimum testing, let's say mechanical testing, that you need to meet Section 9 requirements. Now, there is the supplementary testing that we talked about. Now, that will be the impact testing. Now, that is also a Section 9 requirement if it's an impact tested welding procedure. Is this all making sense so far still?
Kind of. I think we should also point out that we're doing the bend test to actually test the ductility of the weld,
right?
To make sure it's ductile and with it meets the requirements that it needs to, right? The tension test is like a strength test, and they want to see when it pulls apart, like the material. Our bend test is to make sure that it's not too hard and that we actually have some ductility in the material.
Exactly, and I think there's some criteria there, like you're allowed a 1/8 opening, at least for the welder testing. You are.
Yeah.
You'd have to verify that for sure, but nothing more than an 1/8. So usually a good way to do that is to put a 1/8 electrode over it, and if it covers any of the voids, then they're acceptable. Now, the impact testing, it's going to be the same thing. You have to be aware of how many tests have to be done, and then what the minimum impact values are. Now, there's going to be a minimum any individual test can be, and then there's going to be a minimum average you also have to meet. Now, it's either going to be in foot-pounds or joules, depending on what lab does it. And now they may provide both, but that's something you have to review too. So you want to be careful of the minimum average and also the single minimum. And your code of construction is going to have some different requirements around that too. So that's, once you've done your Section 9 review and you're looking to your applicable code of construction, you want to check those requirements too, because they may be different.
That's right. They normally take averages, though, because those impact tests can sometimes be a little sketchy and be all over the place, right? That's why you have a minimum of 3 specimens you're going to test at. And those impact tests are done at the temperature specified, I think, by client specifications, or where do they come up with those? Is that, like, it's not MDMT, but if you want it impact tested below that minus 29 Celsius, those specimens are actually cooled to what they need to be. They need to be placed within that jig and actually impact tested within a specific amount of time, as so they don't either warm up to be outside of those ranges, right?
Yeah, it's actually quite an interesting process to see. So you cut a sample out, you put a little V-notch in it. That's where the I don't know if I've mentioned it or not, but that's where CVN comes from, like the Sharpie V-notch.
Yeah.
So you put a little notch in it. You chill it to sub-zero temperatures, like super, super cold. Then you take it out, quickly put it in, like a vice grip kind of thing. And then you have a big weighted hammer on like a pendulum, and you let it go, and it smashes into it and breaks it. And it just measures the resistance that material had before it broke, and it'll give you a reading in joules or foot-pounds.
It's actually kind of a weird test, but also a neat test, because as that, it almost looks like a sledgehammer really going
Pretty
down
much,
to hit that piece. It's got a calibrated kind of swing to it, and they'll know, the gauge is measured, so they'll know how much force is actually absorbed by the specimen by how high it swings up after it goes through the specimen, right?
Yeah, exactly. The toughness is the beating you can take, right? How many punches can you take?
And I think the notch is there to kind of replicate almost a weakened state or something like that.
Yeah, because you want it to break, right?
Yeah.
If it doesn't break, you're not going to get a measurement. So
Yeah.
it's similar to the tensile test, how you thin it out at the weld. It's so it breaks there, because that's what you're wanting to measure. If you didn't put that notch in there, there's a chance it might not break, and you won't get an accurate reading. So yeah, that's exactly what the notch is for. It's a destructive test. You're trying to destroy the thing.
Essentially just swinging a sledgehammer into a rectangular piece of material.
Pretty much.
I don't remember which actual like paragraph it has, but obviously there's going to be dimensions and specifications for your test specimens during that impact test.
Oh yeah, exactly. That's all laid out for you. Now your lab you're sending that to is going to know all that information, but definitely review their work. Now, if you're looking at PQRs that say they had impact testing done and there's no lab results with no foot-pounds or anything measured, it just says it was done. Don't accept that. Also, make sure it was done properly, right? Make sure they took enough specimens. Make sure they took enough specimens. Make sure the averages are there. Make sure the single minimum isn't below your threshold. Just a couple of things to look at. Just because there's a report from the lab in there doesn't necessarily mean that they did it right.
No.
It should all be referenceable to that PQR number. Should be on that lab report somewhere. It's very easy to just throw these, not that people do this, but it's very easy to just throw a bunch of reports in with each PQR. So you just want to make sure all that traceability is there. They're all things you want to look at when you're reviewing this. I don't know if there's much more to talk about with testing. I think one point I want to make with these charts, and this is in the 400. So pretty much after 422, there's a number of charts that gives you testing you have to do. For example, the range is qualified. One point I really want to make with that is be careful of the title of the chart. Not necessarily the title of the chart, but the title of the paragraph or the chart number, rather. It's going to say procedure qualification, whatever limits or whatever testing you're looking for, or it's going to say performance qualification. Those sound very similar. They're spelled very similar. They mean totally different things. So the performance is your welders. So if you're looking to test welders and see what kind of tests you need to do with them, or just if you want to review their 484s or something like that, that's where you're going to look for the performance information. If you're looking to build a procedure or to review a procedure, the information you're looking for is the procedure qualification, ranges or testing required, or whatever it is. Now, you shouldn't start in QW400 and just start grabbing charts and trying to put it together. The way to do this is how we did at the start. Grab your variables table for whatever applicable procedure and go through it top to bottom. If you follow those reference paragraphs, go to them and then follow the reference chart, you're not going to go wrong, because eventually you're going to come to a dead end at a chart, and that'll be the information you need. Don't start jumping around in QW400 and trying to put charts to things. Start with the variables table, follow it to the reference paragraph, follow that to the reference chart, and that's usually where that ends. Don't start chasing things around that you don't need to. You'll get yourself into trouble.
Yeah, it's extremely difficult to get confused, or it's easy to get confused and go through all this. And I'm just looking through here. I think, there's a lot of information in here, and it's just like everything else in ASME, it's flipping back and forth and all through stuff to kind of piece it together. So I think the way Scott, kind of advised is, well, that's how the people who constructed Section 9 laid it out. Is your first column there is just going to have your paragraph and your paragraph, subparagraph kind of portion there, and just follow it and make sure that everything is aligning. And that's the easiest way to follow the rabbit down the hole.
Yeah, exactly. I had something I was going to say there, and it just escaped me. Got lost in your eyes.
Oh, jeez. I've been lost in my own eyes here since you started going through that first chart, just trying to flip back and forth and keep up with you.
Yeah, so what we were saying about the variables chart, I find the best way to do this, and I think I've said this a few times already, print it off, have the chart, and then have the electronic copy of the code open. And go to the page that your chart's on, click the hyperlink to the paragraph, read the paragraph, click the hyperlink to the table, read the variables on the table, find your answer, go back to the original 250 chart again and start over. It's very nice, the electronic version, using the hyperlinks, and just follow those. Very easy. It's really easy to get mixed up in in the QW 400s because the tables are all next to each other, and procedure and performance are very similar looking words. Having said that, I think we beat this section 9 to death. Should we go on to construction codes a little bit?
That's up to you. We've been going pretty long. I don't know if we might need to split this up into 2 episodes or not.
Is it a full one, do you think? Should we
oh man.
Should we wrap it up here and then maybe restart at part 2? I think we could maybe even do another part 3 and get into the welders some more detail. What do you think? Should we do that?
I think we might have to. This is already, we've been recording for an hour and 45 minutes.
Okay, let's wrap it up here. I'm sure everybody's very eager to hear about the construction code. All kidding aside, though, you should be. There's some major differences there with the construction code that I really want people to be aware of. With the client specs too, but we can't really get into those because we don't really want to use anybody's client spec per se, but we'll maybe reach to some past experience with that kind of stuff. But the construction codes, we're going to use 31.3 and section 8 as some references, and we're going to go through a couple things there that we think are important that you should be aware of. And even some things that they've changed that I don't really agree with. And in some instances, the WPS will supersede the code. So kind of some interesting takes there.
Yeah, no, Scott, your knowledge knows no bounds. And just listening to you is like listening to a symphony of welding knowledge just fill my ears. So I was happy to sit down with you and kind of listen to it.
I'm glad it made you happy.
Oh, geez, that was really good. But
it was fun. This one, very involved. I thought it was going to take a while, and yeah, it's going to.
Yeah, it did. Yeah. So no, it's pretty good. Yeah, it's going to be exciting to start going through the code aspect of it and see how all this applies to the actual fabrication and repair of this stuff and how it gets applied. So
yeah, I think maybe to start part 2 of this, we'll do a nice overview, quick overview, and I hope that will clear that up. I'm quickly finding out that this is very hard to dumb down and explain in simple terms because it's not simple. It is I don't know if it's like difficult's the word. It's kind of a daunting code to first get into, and it can be intimidating, but it's just repetition, and you just got to get used to how it's laid out, and you just got to have a method for following it through. So maybe we'll do another quick overview, and hopefully that clears it up. But
yeah, no, I think the most complicated part of it, especially just listening, is the fact that you're jumping back and forth to either table numbers and or paragraph numbers, and you can't really visualize tables unless you have them in front of your face. So maybe even for the YouTube video, something that we do, like for those of you who don't know, we actually have a YouTube channel, is we might be able to put these tables and charts up so you can kind of follow along and reference while we're talking about it.
Yeah, like we could even probably jump through the hyperlinks or something to make an interesting video of that, just to see how that process works. Maybe a good visual. I don't know.
We'll see. That's a really good idea, because normally when we're going through this stuff, you're in a classroom setting with either PowerPoint presentation or the actual tables and charts up there, and you can follow along. So that's something that we might need to add for the visual reference and go from there. What do you think?
Well, cue the music.
Yeah, cue the music. Thanks for listening, and I guess we'll see you in part 2.